Okay, so there are three ways to determine if triangles are similar. Now, obviously, if we have all of the angles, let me back up. Well, if we have all of the angles and all of the sides, we can figure it out, okay? And that's what, like yesterday, I think there were a couple problems where you had to determine, like the first couple problems of your homework, right? You had to determine if you had similar triangles or not, okay? So now we're saying, okay, here are some triangles. I'm not going to give you all of the information, but that's okay, because there are three ways to determine if we have similar triangles, given only a portion of the information. Okay, so the first one is angle similarity. If we know that two corresponding angles are congruent, then the triangles are going to be similar. Okay, why only two angles?
You can figure out the other angle.
Yeah, because then we'll know the third, right? So like, look at this guy right here. We know that 75 is congruent to 75, right? Using our triangle sum theorem, what is the measure of angle C? Is it 31? Okay, so we know that these two angles are congruent. Well, if we know two of the angles are congruent, doesn't that automatically make the third one the same? Right? Okay, so since we can pick two pairs of angles that are the same, we know without having to do the math that the third pair of angles are going to be the same. And we can say, okay, well, triangle ABC is similar to triangle, how would I have to name the next one? Okay, DEF by angle. Okay, Ben, how did you know that it was DEF? Good, it has to be the same order that the first one is in. So if I follow from 75 to 74 to 31-degree angles, okay, we know we have to match up those corresponding pieces. Okay. Okay. How about number two? Now, number two, we don't have exact measurements, do we? That's okay. Because what is something that we can do in this picture? Ooh, we have some vertical angles. We know that these guys are congruent right here. And I'm going to use another color to mark this one right here. So we know we have these orange angles that they already told us were congruent, whatever their measures might be. We have these red vertical angles that we know are congruent, whatever their measures will be, okay? So no matter what, whatever's left over out of 180, W and Z will have to be the same, okay? So as long as we have two pairs of angles that are congruent, we can say, okay, triangle WXV is similar to triangle, what corresponds with W? So ZXY by angle. So no, you're basically just gonna have to tell me, yes, they are similar by whatever, or no, they are not. Okay, so we're gonna kind of flip back and forth. What I want you to do is turn to page 4, please. Okay. And I want to look first. What do I want to do? You know what? I'm gonna have you guys look first. I am gonna give you a handful of minutes to, at your tables, talk about these 6 problems and tell me what you think about if they are similar or not. The only option would be angle, angle. That's the only one we know. Okay. So I want you to look at these 6 and tell me what you think. Ready, set, go.
I don't think the second one is. Yeah.
Parallel lines have cool things that happen.
Yeah, no, I don't think the second one. Transversal. Third one is. Wait, hold up. Third one is. Third one. I think. Two is reminding one. Because you can use the transversal theory for both angle Q and angle P. 1 and angle M. 1, 3, 4, and 6 are yes. Angle M is congruent to angle Q, and angle N is congruent to angle P. And if we use the 2 angles in each of them, we can say that.
Wait, the proportion equation or something?
Yes. Hold up.
This is the
Wait.
statement of proportion.
Yes,
This is 68 and 54. They
2 is no, 4 is no.
Figure out what the minimums are.
Well, number 5. Where would B and E are? They are the same. Yeah, because D and E are the same.
4 is yes.
I mean, like,
Because you can fill them in.
no, but not.
Yeah, not the angles on
We have to turn. 5 is no.
Oh. Okay, so I'm hearing some really good arguments and I really love it. Okay, let's talk about number 1. Okay, and we'll actually write the statements too. Alex, did you guys think that number 1 was similar? Okay, what angles did you mark as congruent? I'm asking Alex. Thanks. Yes, we have alternate interior angles. Okay. Okay, so we have 2 sets of angles we can mark as congruent. Okay. So we use some alternate interior angles, some vertical angles. So everybody make sure you write down that triangle CDE is similar to triangle GFE, okay, by angle, angle. Okay, I need that whole statement. All right. All right, number 2, Ben, what do you think? Ben says no.
I agree.
Really?
I mean, even though there's 2 angles, the sides don't really match up.
Oh, I don't care about the sides right now.
Well, then they are congruent because there's 2 angles, which means we can use angle.
Okay, so parallel lines, transversal. Couldn't I say that these 2 angles are congruent because they're corresponding? Okay, hold on.
Can you also say P and N?
I didn't say that. It's not a triangle. This woman, the other one, the top shape of there is not a triangle, so you can't. No, it's talking about.
Oh, my dear, we have this cute guy right here, right? And then that I can't quite.
We're the bigger one.
M and L is like the big triangle. Do you see it?
Oh my stop, bro.
So it's like a triangle inside of a triangle. So one thing, okay, so we've talked about M and Q being congruent because they're corresponding angles. We could also talk about N and P, or we could talk about, hey, angle L is the same as this angle L. Do you see that? Yeah. So we can say that triangle MLN is similar to triangle QLP by angle. Isn't that nifty?
You know, I knew that all.
So if it helps to like draw the big triangle out so you can see that, go for it. Okay. Alexa, did you guys decide 3 was a yes or a no? Okay, so you're saying that angle S is 51 degrees if we do the triangle sum theorem. So we have triangle YES is similar to triangle CHW by angle. Do you agree? Awesome. Okay. Now, number 4 sparks more argument than I was anticipating. If we do the triangle sum theorem, what is angle B? 58 degrees. Do we have 2 angles that match up?
No.
These are not similar, people. Okay. Okay. Number 5 is another one where you might have to think about the big triangle and the little triangle. So I highlighted this purple triangle.
Say the same thing because these don't have parallel lines in them.
That's okay. What is the measure of angle M? So what's 180 minus 67 and 25? What is it? 88. Oops. So this is 88 degrees. If I draw the small triangle, what would this angle be right here? What was it? 22. We don't have angles that are matching up here. Darn it. Okay. Ooh, what about number 6? We have vertical angles. So triangle PQX is similar to triangle. What corresponds with P? So ZYX by angle. Okay. All right, let's go back to page 3. Let's talk about side proportionality. Similarity, sorry. I'm getting ahead of myself because to test for this, if all sides are proportional, then the triangles are similar. Okay, what does that mean? Every single pair of sides needs to have the same ratio. Okay, so we would need to test 3 fractions to make sure they all were the same ratio. Side. So take these 2 triangles right here, for example. Okay, how would I know which ones to match up? These 2 are oriented the same, so that's wonderful. But how would I know what to match up with? Let's choose like 3.
You can match it up with 6 because we can't go into any other one, I guess.
No.
And also QP equals to TS.
We don't know that. mathematically, what's true about side 3?
It's half of the.
Okay, is it the smallest?
Oh, yeah.
So in triangle 2 at TSU, it would match up with the smallest, okay? So I'm gonna write 3/6. Okay. The biggest side is 5 and 10. So I'm gonna write 5/10. And then our middle sides are 4 and 8. So I'm gonna write 4/8. Sure about those fractions. Okay. They are all the same. Okay. This means our sides are proportional, and we can say that triangle PQR is similar to triangle STU. Stu, I know, what a great name there. All right, let's look at this next example. Okay, what's the smallest side in CDE?
30.
30. What's the smallest side for FGH? Okay, so those two have to be friends. Let's do 30/24. Okay. What's the biggest side in CDE? 35, which would have to match up with 28. Okay. And then 32 and 25 are going to be friends. Okay. We need to determine if these all are the same ratio. So if we simplify 30/24, what number goes into both of those? 6? That would be 5/4. Okay. What number goes into both 35 and 28? Conveniently, 5/4. Uh-oh. Can we reduce 32/25? These triangles are not similar because our sides are not proportional. All 3 fractions have to be equivalent. Okay. All right, so we're gonna go back to page 4.
4. 4 and technically 5.
4 and technically 5. So let's talk about, I want to highlight a couple of these. Number 8. Okay. Here's that like triangle within a triangle that our eyes are kind of having a hard time with. Okay. So what I'm going to do, I'm going to highlight WVX. Okay. And then I am going to redraw WUY. Okay. We know that this side is 56. How long is technically WY? This is technically 21. How long is WU? 28. So when we go to make our ratios, we're going to put 15/21. And we're going to put 20/28. And we're going to put 40/56. These two sides, these two sides, these two sides. Okay. Brayden, what is 15/21 reduced to? 5 what? No. 21 divided by 3.
5, 7.
Yeah, it's okay to be wrong. It's okay. Don't panic. Okay, Sam, 20/28.
5, 7.
Everybody, 40/56.
5, 7.
Okay. Awesome. So we can say that triangle WXV is similar to triangle WYU by side. Now, you are technically not writing a proof, right? We all decide that this is not a proof. But I need to see your work that you checked those three fractions, those three ratios. Okay? So what I want you to do, I don't want you to talk about all of them, but at your table, I want you to talk about numbers 7, 10, and 12. I'll give you a few minutes to talk about those. If you want to use your calculator to see if 9/14 is the same as 27/42, is the same as 13.5 over, I can't read it anymore.
27.
3s and 9s.
It's not.
You know what? Don't do 10, just do 7 and 12. Will that be okay? Okay. Brady got 7 is yes. He thinks. Only do 7 and 12. I have them highlighted up there. And my goal is for you to like talk about them, and it's kind of quiet, so make sure you're communicating with your people.
Number 9.
Yes.
Well-
It's not so small.
We're supposed to do 7 and 12.
This is why we communicate. Only if it helps.
Yeah. So this is 8 over 20.
Yeah, number 12 is no. There's a 13.5 and 1.5.
Okay, so in number 7, you should be getting yes. All of these fractions are equivalent to 9/14.
And divide 13.5 and 21 with 1.5.
Okay, so something I did to make this easier, like I doubled both of them and it was the same as 27/42. So then I knew I could reduce it to 9/14, okay? Or I could have multiplied them both by 10, 135 over 210, and then we could solve from, reduce it from there, okay? My biggest question is what corresponds with K? What corresponds with N? Okay, so K and R is similar to DES by side, side, side. Okay, now in number 12, when we made our fractions, okay, so some of you said, ooh, you know what? I'm gonna make my big triangle. So this side is 24. This side is 15. What is side AD? 20. So you could make your fractions 8/20. You could make what 6/15 and 9/24. Are these the same?
Besides 9/24, that doesn't match up with the 2/5 of the rest of it.
So this is 2/5 and this is 2/5, but this is not 2/5. Oh, that's sad. Okay. You see it? Okay. All right, so the last way we can have similarity in triangles is side angle side. We love some good side angle side. So 2 corresponding sides are proportional. And here's the important thing, the included angle. So we're kind of going back to what we were doing at the end of the semester, right? That SAS, that angle has to be in between. Okay. So if we look at this example right here, notice how we have 2 sides on each, and notice how the angle is in between, okay? So we have the angle in between. Now, let's check the proportion. Is 8/6 the same as 20/15? What does 8/6 reduce to? 20/15? Okay, so yes, woohoo! Triangle KJL is similar to triangle NMP by SAS. Ooh, somebody didn't shut their sound off. My guess is Braden.
I think it was Brandon.
I don't think it was Brandon.
He's not used to that new phone.
Yeah, he's not used to that.
Ooh, he's no longer a young cat. What do we call him now, Harvey?
Jedi in the way of.
He's a Jedi in the way of the phones. Okay, let's talk about this example. I really like this example. I don't understand how it's side angle side. Where the heck is the angle? Oh, say it louder, Nora. Angle A. Angle A is a part of both triangles. Do you see that?
Could we technically say that is typically reflexive?
I mean, if we had to write a proof, that would be the reflexive property. Okay, so angle A, oh no, angle A is congruent to itself, right? 15/25, is that the same as 12/21? Oh no, is it?
No.
Our proportions don't check out. That's so sad. You're not disappointed.
Yeah.
guys don't care. Okay. Just looking at that, whatever page it is, were there any of these examples that you think it would be beneficial for us to go over before I give you your homework? Okay, so turn the page. Pages 6 and 7. Page 6 and 7 are your homework. How about you get started on some of the ones that maybe jump out to you immediately?
Yeah, no, it's probably your phone.